Okay, today on the bench we have a Bowman CBH-990. I haven't worked on one of these in quite some time. This is a customer's radio. I've got like 2 or 3 of these. I don't know why, I just kind of like the way they look. I like the black look. Can't see it, it's already off, but it is a classic design radio, so it has the faux wood. I mean, they're real wood, plywood, but covered with the vinyl decals, but painted cover, wood end panels. But I've just always kind of liked less is more. When it comes to appearance, I'm not all about flashy, shiny faceplates and whatnot. I like black with a little bit of accent, and well, it doesn't get black with a little bit of accent more than this one. A little bit of chrome rings around there and some chrome knobs, and that's about it. Like I say, that's just for me styling wise. So the customer bought this radio. It has no transmit and receive. Now he has replaced all the electrolytic capacitors himself already. Matter of fact, here's the note. Let's see, Bowman CBH-990, no transmit and receive. Hi Mike, picked this radio up and it never has worked. I watched a lot of your videos, you make it look easy. The only thing I have done is replace the electrolytic caps. Took a chance to replace them to see if it came back to life. It made no difference. Hope I did okay replacing them. See if you can get it going and do your thing. Repair shop had it here and sent it back and said, well, it's an old radio and nothing they can do. Really? And they call themselves a repair shop. It's an old radio, there's nothing we can do. Feel free to contact me if anything. Number is listed. Yeah, so, and he actually did send some, I'm not sure where he got them, but he sent a little baggie full of some surface mount parts. I guess he got a lot of stuff, which appreciated. Oh, never had too many parts laying around. So, first, I have not plugged it in yet. Haven't done anything to it other than to remove the covers and just give it a quickie once over. It is a good, clean looking radio inside. He has replaced the caps. Looks like they're good. I haven't really looked at them. Caps themselves looks like they're all Nichicon. I don't think that one's Nichicon. I see red writing. It's probably a Panasonic Matsushita, but looks like they're all brand name caps. So thumbs up there. This is a PLL02A chassis, so this is a Cybernet chassis radio. This is not a Uniden chassis. And it's kind of hard to see, but it's in there. Nope. Probably can't read the writing because it's underneath the channel board in the shadow. There we go. PLL02A. These are nice little radios. Like I say, I've got a couple of these. I like them. They're small, compact, AM only. Yes, I know some people, oh, Mike, it's not a sideband radio. Well, honestly, most people talk AM. If you take a poll of all of the people that use CB radios, you'll find there's a larger percentage you talk AM than do sideband. And like I say, I really like these. Nice, it's a nice Cybernet chassis. I just, design-wise, and it's a good circuit board. But obviously, this one has problems. It doesn't receive or transmit. Now, without even plugging it in, first things I would suspect would be possibly oscillator crystals. If a crystal goes bad, you've just killed the radio. Especially like if the 10.240 megahertz crystal goes bad. If you don't have any signals being generated in the radio, there's no signals to be mixed with incoming signals, and there's no signals being generated inside. That means there's no way for it to generate signals to leave the radio. Any problems in the PLL area. Now, could be power supply related, affecting those circuits, but like I say, those are the big things that can kill everything that a radio does. PLL synthesizer. Can't even remember. Does this have PA? Yes, it does have PA. We'll have to check the operation of that. Not that anybody ever uses that. Doesn't look like the power supply has gone up in flames. Looks like he did a fairly decent job soldering. I am going to clean up a few, and I think and this is just something, if you're going to recap your radios, it just takes practice. As with anything in life, and I always say when you're working on radios, practice, practice, practice. removing and replacing electrolytic caps can seem extremely easy. And people will say that, oh, well, that's all you gotta do. Just desolder two parts, two leads on one side and pull the cap out the other side. It's not quite that simple, because you have to locate the terminals on this side of the board. You usually do this when you're recapping a radio. You'll have it standing up on edge. You'll be grabbing the cap from this side, but you have to look around the radio over here, see where the cap is, and then locate the two terminals on this side of the board to desolder them. That can be tricky. It seems simple. Now, for me, it is simple. I've been doing it so long. The one piece of advice I can give there to make it simpler is, I often tell people spatial awareness. If you hold your, if you ever get pulled over for a, what the heck do they call that? Field sobriety test. The cops tell you to, hold your arm out or hold your hand out at arm's length, your pointer finger, close your eyes, and bring it in and touch the tip of your nose. That's spatial awareness. If you're not drunk, the tip of your finger knows where the tip of your nose is. Well, the same thing goes for two fingers. So if you put your finger on a part on this side of the board, let's say, I'm trying to find one here at an arm's length, that cap right there, I can just, without even looking at the bottom side of the board, spatial awareness, my brain knows where this fingertip is. My brain also knows where this fingertip is. And it's really good at bringing them together, just like that. So what you can do is just put a finger on top there, and then just bring your other finger in, just like you were trying to locate or touch the tip of your other finger. Well, something's going to get in the way. It's the circuit board. Now, by doing that, you may have missed it by a terminal or two, but it's going to be right in this immediate general area. So you've located it to an area. The other thing to do is look for components on the top side of the board that can be easily identified on the bottom side. The easiest parts to locate on the bottom side of the board are integrated circuits, so like this audio amplifier, the PLL chip. Okay, there's another SIP package IC right here. Transformers, another thing, very easy to find. They'll usually have these mounting straps attached to the bottom. Same thing goes for all these tunable coils and transformers in here. They're extremely easy to find on the bottom side of the radio because these cans are soldered to the ground plane, so they have big flat terminals. And you can just flip the radio over here and see how easy they are to find. So, like the transformer, okay? It's fairly easy to look in this radio and see there's two big ground pads right there where the two tabs for that transformer come through and solder to the ground plane. Things like transformers, again, like I say, they're very easy to find in integrated circuits. So you've got ICs. ICs have a big long row of straight terminals. So there's the audio amplifier. You've got an IC, another SIP package IC right there. You can see the long row of straight terminals. The PLL chip, no difference there. Easy to find a PLL chip that's a dip package, so it has two rows, dual inline package, very easy to find. The transformers, let me get a pointer here so my finger's not in the way. Any of those tunable transformers and coils are also very easy to find. You'll see these kind of flat tabs sticking through. Now some radios will have a hole drilled in the middle of the circuit board. This one does not, but that's just something to be aware of. Some radios in the middle of the coils or the transformers on the circuit board itself, it'll actually have a hole drilled. Like I say, this one doesn't. But look for those two tabs. So if you're looking on the top side of the board for an electrolytic capacitor that's, let's say, over here, find that transformer. You can just easily look at the bottom side here and see there's a transformer or coil there. There's one right here. You can just look through this radio and just easily find those because of those long, they look different than everything else. It has small little round pins sticking through. You got this flat metal sticking up out of the board. Makes it easy to identify. Because the problem I frequently find on a radio, and it looked like he may have done it in a few spots, corrected most of it, but what you'll see is, or what I see, is someone recaps a radio, and it's their first attempt, first or second radio they've ever worked on. Don't plan on becoming an expert overnight. Like I say, practice makes perfect. You'll see a disturbed solder joint. You'll see another disturbed solder joint. You'll see another disturbed solder joint. Now these aren't, but I'm just using it as an example, and this one might be disturbed. And then you'll see two that were resoldered. Well, that was the part that they actually replaced. but it was, you know, they were kind of going around blinded by, they knew it was in this area somewhere, so they're touching that with a soldering iron, trying to move the part. It's not moving. They touch the next lead, they touch the next lead, touch the next lead, touch the next lead, touch the next lead. They finally get to, okay, it moves. It's that one. The problem is, when you come in with your soldering iron and touch that connection, there's a good chance you're going to pull solder off of the board. You've also now disturbed the solder. You didn't add any additional flux, so that solder connection is no excuse me, that solder connection is no longer a good, proper solder joint. It's going to easily fail because it's now a cold solder joint. And I can see a few of those in here. One thing that did catch my eye, and I'm not sure if he did it, there's, let's see where we at in the camera view here, right there. That pin, that is a wire tie post. Yeah, cybernets are known for using their camera here, right there, stuff like that, wire tie posts. So you can see the wires wrapped very tightly around there with a little tool that does that. I have those. But this is one that's mounted on the top side of the board. It looks like that was desoldered. There's just no solder on that thing anymore. Look at that from an angle. I don't know how well it's focusing on that or not. But there's really hardly anything on that. So again, when you're done, probably the biggest thing is, change your caps. If you want to recap a radio, change the caps, then come back, clean the board off. Clean all the solder flux residue off. That makes any imperfections or stuff like that very easy to see because you've gotten rid of all the flux residue. Now, cybernets, luckily, are usually cleaner to start with than Unitins. Unitins, man, I've seen some of those things. The bottom of the boards are just brown with flux residue. You can barely see the solder connections. But yeah, clean the solder flux off and then look for disturbed solder joints. If you see one that you had come in and touched with a soldering iron, which actually I think that one is, that is a disturbed solder joint right there. You know, you had disturbed it. That needs to be resoldered with flux. Like I say, heating it up with a soldering iron, when you pulled the soldering iron away, there was a good chance you pulled some of the solder off. And it's not properly bonded anymore because it's old solder and there was no flux there. So just do yourself a favor, just go through and check. Like I say, it looks like he did a good job. There's a few things I just need to touch up, but overall, you know, I'd give him an A for effort and probably a B or a B plus in soldering. Like I say, that I'm not sure if he did that or not. Is there? Yes, there is he probably did that. Because there is an electrolytic cap on the other side of the radio, right close to that post. And I'm not sure what he used to desolder, either a desoldering iron or desoldering braid. But yeah, it looks like most of the solder got sucked off of that pin. But, you know, beginner mistakes, that happens. So the other thing is, of course, this radio doesn't work. It doesn't receive or transmit. So while we're down here, we want to just look it over. You know, no burned wiring. Luckily, it doesn't look like there's any modifications. I haven't given it a really good look over, but just from a general glance, I can't say I see any cut circuit traces. It doesn't even look like the... I don't know. It looks like the PLL... maybe somebody reflowed one or two of the solder connections on it over here, but it does look like all of these look like they're original solder joints. But just give it a quick inspection. Check for cold solder joints, and I'm not talking about ones that the customer might have caused. I mean factory original soldering. It's just a broken out solder joint. Check for bad solder joints. Check same thing on the power supply board. Make sure you check the power supply board. So let me get this taken care of. Like I say, I'm just going to clean the board off, touch up a few of these solder joints, then I'll power it up, and like I say, we should be able to get some good basic diagnostics out of this. No receive and no transmit is usually a fairly simple problem. Now, not necessarily going to be simple to find the problem, but usually in my experience, when a radio doesn't do anything but basically turn on and have a channel display, they're usually fairly easy to diagnose, because it's usually a major failure. The oscillator circuit's not working, the synthesizer circuit's not working, there's a power supply rail that's, you know, maybe a bad voltage regulator transistor somewhere that's, you know, not sending voltage throughout the entire radio. So I shall return. Okay, so I have resoldered any questionable solder joints. I cleaned the circuit board, inspected it, everything looks good. Nothing obvious that could be causing any problems with this. So I did power it up, and that's about all the farther I've got. No, I did do one thing. Before I even powered it up and cleaned the circuit board off, he had replaced all the aluminum electrolytic capacitors. This is just something I know from experience. I did replace 2 tantalum capacitors in this. Usually I don't replace tantalum capacitors, but this has these brown ones. If you're familiar with tantalum capacitors, usually these dip style tantalum caps, they have like a shiny surface. These ones that are kind of dull, these are old school kind of, and in my experience these things do fail quite frequently. Now it's not that there was anything wrong with them back in the day. Gotta remember, old radio. Service manual from Sam's came out June of 1978, so this radio came out before that date. So, you know, but just from experience, I've seen a lot of this style from whoever made these go bad. So I just by default replace these anytime I see them. So that's one additional thing I have done to this radio. I did replace these 2. That apparently didn't fix the fault because it still does not transmit and receive. So that's all the farther I've gotten. So we turn the radio on. We can see the display does work. Actually, if we hook up a watt meter and dummy load, and hook up the microphone, and you can hear we did have sound when I just plugged in the microphone, so that means at least our audio circuit is definitely working. And if we look over at that watt meter back there, and I key the mic, and we look down here at the radio, at the watt meter on the radio, and yeah, it's not doing anything at all. Now, one thing we do notice is that the receive light is on, and when I key the mic, it does switch to transmit. So that right there does tell me that at least the receive transmit switching circuit is working. So that's one thing eliminated. So probably the first thing I'm going to check, like I say, common problems that can cause basically a dead radio with the exception of it turning on if an oscillator crystal goes out. So this radio has 2 crystals. It has a 10.240, which it's a 695, so that should be this one. Yeah, okay. So this has 2 crystals. This one down here is the 10.240 megahertz, so that's the reference oscillator crystal. And then this one here is a 10.695. This is a transmit oscillator crystal used for mixing to create our, whatever channel we're on frequency when we're transmitting. So the first thing I want to do, probe at those with an oscilloscope just to see if they're oscillating, because if that is not oscillating, this one doesn't matter. I mean, that only matters in transmit, but if this crystal is not oscillating in receive, that would explain all of our problems. So let's turn on a scope. And let's see. And again, we come down to how to locate parts on the back, because there's no real easy place up here to probe to get at that crystal, so I'll just probe it on the back of the board. So we can see there's 2 wire tie points right there, so I know there's going to be 2 square pins sticking out the back side of the board. The trimmer capacitor for that crystal is right behind it. So that should be something else, that little trimmer capacitor right there. That should be something else that's fairly obvious on the back side of the board because it does not have round pins. And then the crystal is right at the top side back from that. So I look now. Remember, when working on something like this, I have this radio powered up by 120 volts. Of course, everything up here is 12 volts, but right there is 120 volts. So be careful where you're sticking your fingers at. You can kill yourself, or at the very least get one severe shock. Okay. Let's see. I'm going to move the camera up here for a second. I got to get in here and take a look. Okay, where was I on the board here? Right there. We got pin. So that should be those two connections right. See if we can get zoom backed out here. See the scope over there. Okay, should be that one, and we definitely have a signal. So, and the scope has a little frequency count. You probably can't see it, but I can see it. It says 10.239. Really doesn't matter. It's close enough for troubleshooting purposes. So it looks like our 10.240 circuit's working just fine. So I'm not going to worry about the 10.695 because, like I say, that's only used in transmit, so there's no need to even check that. We know our problem is in receive and transmit. So anything in the PLL, and I have a sneeze coming on. Okay, maybe not. So anything in the PLL synthesizer circuit, the VCO circuit, if we have a fault, basically anywhere in this area right here, that will kill the radio. No transmit or receive. Because all of that is associated with frequency generation for receive and transmit. So let's just first make sure that we have 10.240 making it 2, because just because we got 10.240 at the crystal doesn't necessarily mean that we have anything being received at the PLL chip, because there's still a lot of other parts in its path. Let's see. I actually got to look at the schematic. PLL02A, I'm thinking pin 3 or 5. Pin 3. So let's see here. Where are we at? Okay, so right there, 10.240. And yes, anytime you see me when I'm working on a radio, I pretty much have all my SAMS manuals marked up like this. You'll see I highlight things. It just makes it a lot faster. Just like right now, I don't have to hunt on this schematic to find a 10.240 crystal. It's right there. It's been highlighted in pink. I always highlight the test points. I always highlight or variable resistors, be it an external like a volume control or an internal adjustment. I always highlight all of those, and I always highlight crystals. Things I just naturally are some of the first things I always look for on a schematic when I'm diagnosing something. So there's our 10.240. So like I say, there's going to be some components in between it and the PLL, so there's no guarantee that just because I probed at the crystal and I have 10.240 here doesn't necessarily mean that it's making it all the way over here to the PLL chip. Because you can see we have the reference oscillator transistor, there's a coil, there's capacitors in line. Actually, we're down here at the buffer. So, you know, if the buffer went bad, come straight across and in pin 3. So we want to test at pin 3. And I also want to see what I have at pin 5, which is basically, you can consider that the output from the PLL. So, yeah, I'll never get at least I'll never get me probing in, in view. Let's see, 1, 2, 3, 4. 1, 2, oh, I didn't want 5, I wanted 3. So there's 3, and 10.240, right on the nose. So our 10.240 is making it to the PLL, and I'm just switching to DC. I'm going to go to pin 5. And I'm changing the channel selector. Well, I don't have anything basically coming out of the PLL. Doesn't seem to be doing anything, so the next thing I want to check. Let's have a gander at the schematic again. It's probably going to be the VCO mixer. probably to make sure it's working. So let's see, TP8. That should be our test point for, and there's our tank, the transformer for a coil for adjusting the VCO voltage. So let's check at TP8. And we can just verify that. 3.6 volts. Yeah, DC meter, TP8, channel 1. Actually, we don't care what channel. We just want to see if it's actually adjustable. And TP8 is, looks like probably the resistor underneath of, so that's probably either going to be a 3300 or a 22K, so either R1 or R2 is what I want to look for down there. So either starting with red red or orange orange for the bands, the color code, and looks like right there, yep, or it's underneath a little bit of wax. Yeah, that should be it right there, that resistor. So right here at this point should be TP8, so that's going to be checking our VCO voltage. And what I want to see is, does that change when I change the channel selector? More importantly, does it change when I adjust the coil, the tank coil for the VCO? So, get a voltmeter turned on there. Grab some probes. Just pick a convenient and you can't see the screen. Let's see, system, display, invert. And yeah, you can see that now. And I can't see down in the radio. Okay, we got 5.605 volts, and I'm changing channels, and it would appear nothing is happening. The voltage is not changing. And if we try adjusting the tank coil, nothing. Yeah, a couple hundredths of a volt, but that's irrelevant. I want to see a huge voltage swing, and I'm not seeing a big voltage swing. So it would appear the VCO circuit is dead. It is kaput. I'm going to assume probably a bad VCO mixer if I had to take a guess. Actually, there's those two capacitors. I just looking here. So the 0.1 and the 0.22 tantalum capacitors, they're actually right there and there. Those are the ones I had already changed. Just like I say, I just familiar with those going bad and causing problems. That style, or like I say, whoever made those kind of dirt-colored, non-shiny tantalum caps. So I know those aren't bad. Like I say, I'm just going to say it's probably the VCO. I don't want to say that's a common problem, but yeah, you'd be surprised how many of those you find if you work on old radios that have gone bad. So this is a C3001A. So let me... I got the app on my tablet, because that's what I stock all of my parts by, is by NTE number. They're not NTE parts, I just use their numbering system because it's very easy. And it's an NTE 1192. Okay, look that up. 92. Okay, should be in drawer 31. see here. Okay, AN103, which is the same thing. Actually, it's the NT1192, AN103, a TA70, 7310, the C3001A. They're all the same IC. So let's grab a new one. And back in there. And let's get this little critter replaced. Turn on the desoldering iron there. Let's move the schematic out of the way for a moment. And that's going to be that IC right, just out of camera view, that's going to be that IC right there is going to be the Vco mixer. Now, unplug the power cord here. Don't want to be working on a radio that has power to it. Get my finger on there so it doesn't fall out. Actually, wrong pin. Where are we at there? Or was that the right pin? That was the wrong IC I pointed to. Actually, that is the one we want. I'm trying to look at from like 3 feet away at this thing at arm's length here because of the camera. Actually, it's that IC right there that we want. Both dip packages, I was just pointing to the wrong one. Okay. Okay. Suppliers. Okay. Yep, C3001A. And we'll get our replacement, and actually the replacement I grabbed is a TA7310P. Like I say, it's that and several other ICs, they're all the same thing. It just depends on what manufacturer they come from, what part number they happen to use. And we'll just get a couple pins here slightly bent over. Turn on the soldering iron. Grab a roll of solder. Trying to keep this in camera view. Trying to get that camera swung around here so it's not in my way. There, that ought to work. Okay, camera, you're just going to get in my way, aren't you? Okay. Wipe here. Okay, and let's see if it's been successful. Solder back out of the way, turn off the soldering iron, it's already off. Okay. So, get back to where we can see the voltmeter again. Get our power hooked up. Turn the radio on. And move the camera here for a second while I get my head down in here to see that resistor. Okay. And, well, that voltage is lower. Let's see. We wanted what? Channel 1. Aha! We're changing. Or maybe not. Or I might need... Aha! Oh, there we go. Coil. Somebody had the coil almost bottomed out. We want about 3.6 volts. That's good. And I guess we can hook up our wattmeter dummy load again and see if she works. Actually, we don't even need the external one. We just need to see if we have deflection on the radio here. Aha! And we have deflection. Just a hair under 4 watts, so it looks like it's doing about 3.8 watts. Let me turn the communications test set on over here, and we'll see how receive is. But I'm going to say we've had a successful repair, so it wasn't too much to troubleshoot, unfortunately. But you did see a little bit of the process at least. Now, like I say, a lot of this comes with experience. Probably the biggest tips I have, and you would have been able to actually fairly quickly, because that's actually one of the first things in the alignment, isn't it? Yeah, number 3. I've said this before, and I'll say it again. If you're new to working on radios, a good place to start is the service manual. Especially for no receive, no transmit problems, start with the synthesizer alignment. If it just basically go through, even though the radio isn't working, go through the synthesizer alignment. If any one of these things in the synthesizer alignment, you can't get it to adjust, or you don't see a frequency, like, it says input a frequency counter to TP4, IC3, pin 4, radio in channel 1, check for 37.660 megahertz. Well, if you don't see that frequency there, you've just found a problem. You're missing a frequency, or if it's wrong, it's wrong at TP4, and you can troubleshoot from that point. But in the case of this one, the first step would have been the 10.240 reference oscillator adjustment, so that would have been fine. You'd have seen your 10.240, no problem. RF vacuum tube voltmeter to TP2, that's probably, I'd have to look at the schematic, that's probably actually the 10240. Let's see, T1, yeah, that's actually for the 10.240 megahertz reference oscillator, so that would have been fine. You would have peaked that on channel 19, but when you got to step 3, input a DC meter to TP8, adjust for 3.6 volts, you would have found that you were stuck at whatever we had, like 5.8 or 5.9 volts. Okay, so communications test set has booted up. What do I have that on? Channel 20. And I have it set to, I'll get zoomed in here. The camera leveled out a little bit too. So we have the generator set at minus 110 dBm. So, receives so-so, but it hasn't had an alignment yet. And check transmit. And what, 27.205, oh no, actually marker peak. Yeah, so it's transmitting 116 hertz high. That's actually not bad. Hasn't had an alignment done yet. And looks like modulation's good. It's not over modulating. So yeah, we're basically, all I need to do now is transceiver alignment, and this radio would be ready to send back to the customer. So, you know, here's a good example of a radio. Customer got this, didn't work. He replaced the electrolytic capacitors, so he saved himself money there. You know, he bought the parts and installed them himself, so he saved, you know, labor costs. He didn't have to pay me to change the parts. It was still beyond his abilities to repair it, so that's fine. But he saved some money. You know, that money that he saved in labor recapping this radio himself, well, he could put that towards another radio, you know, or whatever, a car payment, it doesn't matter, pay for your house, buy your kid a whatever. But, you know, he saved some money, sent it to me. Once you get to a point, you know, I don't have a problem doing that. And that's, I think it's a good way for people to learn. Especially if you actually want to repair radios, get used to replacing parts for starters. Recapping radios, replacing all the electrolytic capacitors is a good way to get some soldering experience. You'll get experience locating the parts, you know, on one side of the board, and the solder, the actual pads on the opposite side of the board. You'll get experience doing actual soldering on, you know, an actual piece of equipment. And then you can send it out and have, you know, and if the radio worked, all he would have had to have done would be send it to me, I do an alignment, and send the radio back. But, you know, like I say, this one needed some diagnostics done. Luckily, no biggie, just a bad VCO mixer IC. So, yeah, successful repair. So I'll probably go ahead and do the alignment and fire the camera back up just to, once I have it all put back together so you can see what it looks like with the cover on it. But yep, so one of my favorite little AM base stations, like I say, I just kind of like the blacked out look with very minimalist trim, nice looking little radios. So let me get to it and I'll be back.
Going on. I'm still trying to iron out all the bugs out this mobile. Hello, Brian. Mr. Thor back there getting ready. Yeah, right, old mother. I'm gonna do it just that way too, man. I hear 103. I hear everybody in the job. Riding the Carolinas, getting all help myself. Shame on it all. Mother Nature's rough. All right, Mr. Lockhart on the slim pile is getting on down. Reading the spell. Trust and believe, can we use it? There's all kinds of adjustments in it. They only want like 30 bucks for it.
Yeah, it's actually kind of late for Skip, but it's, what is it? About 2 minutes to 9 o'clock at night, that is.
If you're busy, you're having fun.
But still a little bit of Skip coming in.
You'll be surprised. Hey, groundhog, you'll be surprised how much more I need to do to this mobile. Isn't that a groundhog? It's a throw of fire breaking this bad time in this mobile is that right? Roger that, old Cindy 21, no screen, no pain, I got it all, so you see it all, man. Hey, Cindy 21, you signing real? Downtown, beautiful second floor, no doubt about it. Mr. Cindy 21, that's a little kid, got a good one in the second floor, you see, happy Mother's Day. Roger.
It all starting to fade out. Now, this is a basic AM radio. It's one thing it's one of the reasons I do like this radio. It has a tone switch. I'd rather it had a tone knob to make it variable, but it does have a tone switch, and you can really hear. Now, some people don't like that because it cuts out so much of the highs. Personally, I'd rather listen to a narrower audio bandwidth and actually be able to hear a distant contact than hear nothing but static. Because most of the hiss, if we get to a channel where there's really nothing happening, most of that, you know, your sizzling bacon, your background noise, it's all very high pitched. So if you flip the tone switch to low, it gets rid of a lot of that. And in my experience, a lot of times that can be the difference between hearing somebody but not being able to make out what they're saying, and actually being able to hear somebody and make out what they're saying. So, like I say, that's one advantage. It is a basic AM radio, but it does, that's one feature it has that's a nice addition. This does not have a clarifier control. It's an AM only radio. You don't really need a clarifier. Honestly, you don't need a tone or a tune switch. So what they have on this instead of a clarifier is a tune, so you can, you know, adjust the frequency up probably a couple kilohertz or a couple hundred hertz usually, and you know, it'd go down in frequency. If anything, most people would use that switch as a 3-position channel mod. That's the most popular use for that switch. Since this does have a PLL02A, very easy to modify for extra channels. Usually in these radios, because the ones that I have, every single one when I first got them, that was a channel switch, and I had to undo it and put it back to the original position, because all my radios I keep, you know, collector's quality, so they're all original with no modifications. But so in any case, there you go, a CBH-990 made by Bowman. Nice little radio. Nothing like 5 or 6 stations all booming in at the same time. Now, for people like that have their audio is extremely bassy to start with, yeah, probably best in a high position. Yeah, not really much coming in on the mini bowl, channel 11. Okay, that's about all I can handle with channel 6. So in any case, there you go. A repaired and ready to be sent back to the customer Bowman CBH-990.